Imagine your entire life, from the very first breath you take as a newborn to the wisdom of your 100th birthday, unfolding in the time it takes to eat lunch. Every moment, every milestone, every memory, compressed into a single afternoon. The laughter of childhood, the excitement of youth, the responsibilities of adulthood, and the reflections of old age, all racing by in just a few hours. It's a mind-bending idea, almost impossible to picture, yet it invites us to rethink what it means to live a lifetime. Picture celebrating New Year's Eve, not just once a year, but multiple times a day. Imagine the clock striking midnight again and again, each time marking the start of a brand new year. Birthdays would come and go in the blink of an eye, and anniversaries would stack up faster than you could count. The passage of time would feel like a whirlwind, with traditions and milestones happening at a dizzying pace. This isn't just science fiction, it's a possibility in our vast universe. Out there, among the billions of stars and swirling galaxies, are worlds where time moves at a pace we can barely comprehend. The universe is full of surprises, and some planets experience years that last only a few hours. These places challenge everything we know about time, aging, and what it means to experience life. We're exploring a planet where a year lasts just a few hours. Imagine standing on its surface, watching the sun rise and set dozens of times before you've even finished your morning coffee. The seasons would change in a flash, and the landscape would transform before your eyes. On this planet, you could live through dozens of years in a single day. The concept of time would be completely different. Children would grow up, adults would age, and entire generations could pass in what feels like a single afternoon. Life would be a breathtaking sprint, not a marathon. It's a concept that challenges our understanding of time and life. We're used to thinking of years as long stretches, but here, time is condensed, and every moment is precious. It makes us wonder, how would we live if every day truly counted as a lifetime? As we journey to this extreme world, consider how it redefines a year. What would it mean to celebrate a birthday every few hours, or to see the world change so quickly? The very fabric of life would be woven differently, shaped by the relentless pace of the planet's orbit. Out there, planets dance to different rhythms, some in a cosmic hurry. Their orbits are so fast that time itself seems to speed up, creating a universe where the rules we know no longer apply. Each world has its own tempo, its own unique story written in the language of time. These sprinters of the universe race around their suns in dizzying loops. Their years are measured in hours, not months, and their days are over before we can even blink. It's a breathtaking reminder of how diverse and extraordinary our universe truly is. Let's uncover the answers and explore a world on a different timescale, a place where a lifetime can truly happen in an afternoon, and where the meaning of time is limited only by our imagination. Before we set off to visit our super-fast world, let's take a moment to understand what makes it so special, and what exactly we're searching for out there in the vastness of space. When we gaze up at the night sky, we see countless stars twinkling above us. But what lies beyond those pinpricks of light? For centuries, astronomers and dreamers alike have wondered if those distant suns might have their own planets, just like our sun does. You probably know about planets like Mars and Jupiter, our familiar neighbors in the solar system. These worlds have fascinated humans for generations, inspiring stories, science, and exploration. But for most of human history, we could only guess if other stars had planets too. Ancient astronomers peered through early telescopes, hoping to catch a glimpse of something more, while storytellers imagined distant worlds teeming with life. Today, we know the answer. An exoplanet is a planet that orbits a star outside our own solar system. These are worlds far beyond the reach of our sun's family, circling their own stars in the darkness. Imagine every star you see in the sky, not as a lonely beacon, but as the center of its own solar system, with planets spinning around it. Some small and rocky, others giant and gaseous, each with its own story. In fact, scientists have now discovered thousands of these exoplanets, each one a new island in the cosmic ocean. Some are bigger than Jupiter, others smaller than Earth, and many are unlike anything we've ever seen before. Finding these distant worlds isn't easy. It's like being a cosmic detective, searching for clues hidden in the faintest flickers of starlight. Astronomers use powerful telescopes and advanced technology to hunt for the tiniest hints that a planet might be there. Since exoplanets don't shine with their own light, we have to use clever tricks to spot them. Sometimes we watch for a star to dim ever so slightly as a planet passes in front of it. Or we look for the gentle wobble of a star tugged by an unseen companion. Each new discovery is a breakthrough, teaching us more about the incredible variety of worlds that exist and expanding our sense of what's possible in the universe. Exoplanets come in all shapes and sizes. Some are icy and cold, others are blazing hot, and a few might even have the right conditions for life as we know it. The diversity is truly mind-blowing. The discovery of exoplanets has completely transformed our understanding of the cosmos. It's changed the way we see our place in the universe, showing us that planets are not rare, but common. In fact, astronomers now believe there are billions of planets in our galaxy alone, just waiting to be discovered. Each one could hold secrets about how planets form, what they're made of, and maybe even whether life exists elsewhere. And among all these incredible worlds, there's one that stands out, a super-fast planet racing around its star. That's the world we're about to explore together, so buckle up for an interstellar adventure. Let's meet the ultra-short period planets, a rare and fascinating class of worlds that race around their stars at breakneck speeds. These are the true speedsters of the cosmos, planets that complete an entire orbit in the time it takes us to finish a workday, or even less. Imagine a planet so close to its star that it whips around in just a few hours, moving so fast that its year is shorter than a single Earth day. These cosmic sprinters are unlike anything we find in our own solar system. For comparison, Earth takes 365 days to make one trip around the Sun, but these ultra-short period planets can complete their orbits in as little as 4, 8, or 12 hours. That means while we experience one sunrise and sunset, these planets might have seen several years pass by. Take K2-137b, for example, one of the fastest exoplanets ever discovered. Its year lasts just 4.3 hours. In the time it takes you to watch a movie, this planet has already completed a full lap around its star. Imagine celebrating New Year's not once, but 5 times in a single Earth day. The passage of time on these worlds is almost impossible for us to comprehend. These planets orbit so close to their stars that they seem to skim just above the stellar surface, sometimes separated by only a few stellar diameters. The gravitational forces at play are immense, and the temperatures soar to thousands of degrees. Many of these speedsters are known as hot Jupiters, or hot super-Earths, giant gas planets or rocky worlds that have migrated inward, defying what we thought we knew about planetary systems. The intense heat and radiation from their nearby stars make these planets some of the most extreme environments in the universe. Their surfaces can glow from the relentless bombardment of energy, and their atmospheres, if they have any, are often stripped away. The very existence of these worlds challenges our theories of how planets form and evolve. For a long time, scientists believed that planets could only form far from their stars, where it was cool enough for gas and dust to stick together. But these ultra-short period planets are clear exceptions. They force us to rethink the rules, suggesting that planets can migrate inward after forming, or perhaps even form, in ways we haven't yet imagined. Their presence hints at the chaotic and dynamic processes that shape solar systems. Collisions, gravitational tugs, and disk instabilities may all play a role in sending these planets on their wild, close-in orbits. Studying these speedsters gives us crucial clues about how planets and stars interact. Their gravitational pull can even affect the star itself, causing it to wobble or spin faster. These planets reveal just how wild and diverse our universe can be. From gas giants hugging their stars to rocky worlds enduring unimaginable heat, the possibilities seem endless. As we continue to discover more of these cosmic speedsters, we realize that the universe is full of surprises. Let's explore how these planets defy our expectations and reshape our understanding of planetary systems. How do scientists find these distant exoplanets? The star's light drowns out the planets, so we use indirect methods. The transit method is a key technique. Scientists measure a star's brightness for tiny dips. When a planet passes in front, it causes a brief dimming. Telescopes like Kepler and TESS detect these faint dips. For fast planets like K2-137b, transits happen quickly and repeatedly. This repetition confirms a planet's presence. The radial velocity method detects a star's wobble from a planet's pull. These methods together reveal a planet's size and mass. It's cosmic detective work, unveiling hidden worlds. Let's see how these techniques uncover the universe's secrets. Imagine life on a planet with a 4-hour year. It would be incredibly hot, with a molten surface. Many are tidally locked, with one side always facing the star. One hemisphere is in perpetual daylight, the other in eternal night. Extreme weather would whip around the planet at supersonic speeds. Living on the Terminator line, you'd see the star fixed on the horizon. A full year would pass in the time it takes for a school morning. Generations would blink by in an instant. It's a lifestyle so alien, it's hard to comprehend. Let's explore this fast-paced, extreme world. Comparing Earth to K2 137b highlights cosmic diversity. Earth's orbit is a slow, majestic dance, taking 365 days. Our seasons are shaped by Earth's tilt and distance from the Sun. K2 137b orbits at over 1,000,000 miles per hour. Its speed balances the star's gravitational pull. Earth orbits at a comfortable 93 million miles from the Sun. K2 137b is less than 1,000,000 miles from its star. This comparison shows the universe's variety. Earth's slow dance creates a stable, life-friendly environment. The sprint of an ultra-short period planet creates chaos. Studying these sprinters helps us appreciate Earth's balance. It reminds us of the precious gift of our predictable seasons. Let's explore how these differences shape our understanding. Let's explore some fun facts about these fast worlds. On K2 137b, you'd be ancient by their standards. A 10-year-old on Earth would be over 20,000 years old there. These planets might be stretched into egg shapes by gravity. Many orbit red dwarfs, cooler and dimmer than our Sun. This allows them to survive close to their stars. Surface gravity would be crushing, making movement difficult. These worlds are inhospitable, yet fascinating to study. They push the limits of what we thought possible. Their extreme conditions offer insights into planetary physics. They are cosmic extremists, challenging our understanding. Let's dive into the wonders of these unique worlds. Discover how they expand our view of the universe. Imagine standing on the night side of a super-fast planet. The sky would be permanently dark, offering a clear view of the galaxy. The Milky Way would be a brilliant river of stars. On the horizon, a fiery wall of light from the star would dominate. The sky would be split between cold stars and a blazing sun. The planet's speed would shift constellations rapidly. It would be like watching cosmic scenery from a race car. This sky is a reminder of the universe's variety. On Earth, our sky changes in a familiar rhythm. On an ultra-short period planet, it's a static yet dynamic canvas. Why are these super-fast planets important? They push the limits of planetary systems, challenging our theories. They help us understand planet migration and evolution. These worlds test our understanding of physics. They refine our techniques for finding other planets. Their discovery fuels our curiosity and wonder. Each exoplanet is a new chapter in the cosmic story. They inspire future scientists and dreamers. The search is about understanding our place in the universe. Let's explore how these worlds expand our cosmic perspective.